Okay, this is Science for Thursday, April 16th, and we are on page 186 in your book. And so you need to be turned to your notes page, and we will get started. So yesterday we left off with the cnidarians and their stingers, right? Their tentacles that wave and sting. So today we're going to look deeper into that, and we're going to learn about nematocyst. And that's kind of a hard word to say. Let me write it up here on the board. Nematocyst. Let's take a closer look at a cnidarian's intriguing stinging cells, which are called nematocysts. The nematocysts typically cover each tentacle. There could be thousands or even millions of these little cells on one tentacle, depending on how big the tentacle is. Each nematocyst is like a small jar containing an arrow with its own poison delivery system. Okay, so if we have a jellyfish here, and it's got its tentacles, okay, just on one, there could be 1 million of these. Okay, so they're going to be really small. And what we're going to do is we're going to look at one nematocyst cell, just one, and we're going to make it really big. Okay, so that way we can see what's going on that tentacle. This poison arrow jar has a little lid that is closed until something triggers it. So on the tentacle, here's the tentacle. And it's like each tentacle has little jars inside it, and that's these cells. And so we're going to look at this one cell. In many cnidarians, nematocysts are triggered when the tentacle is touched. Other cnidarians have a sophisticated system that triggers it only when a chemical is detected. Once it is triggered, the lid to the nematocyst jar, called the capsule, springs open, and the arrow within pops out. Okay, so this is called a capsule, the little jar inside. And what happens is you're swimming in the ocean, right? And your leg touches, right, this little thing. Well, what happens is it activates, and it has an arrow inside, and the lid's going to open, and it's going to shoot that arrow out. Okay, now what if your leg touches a bunch of those? Well, a bunch of arrows are going to shoot out. Now, some creatures can choose when theirs come out, but some don't. It just stings whatever touches it. Okay? The picture on page 186 does a really good job at explaining what's going on. Okay? The arrow's job is to pierce the skin so that the nematocyst can extend a long, hollow thread into the animal. This thread is coiled up in the nematocyst capsule, but once the sharp tip has pierced the skin, the thread shoots into the prey's body. When the thread enters the body, it extends a powerful poison and is released from the end. All of these events happen very quickly. Believe it or not, once the nematocyst is triggered, it can take as little as 1/1000th of a second for the capsule to open, the point to pierce the skin, the thread to be inserted, and the poison to be released. So not even one. All of that's happened. Okay, so let's take a picture of this. So it shoots this thread that's been coiled up, it shoots it into the skin, and then it releases poison. Okay, and you can see a picture of how that works on page 186. All the nematocysts that are triggered are released at once. As a result, there could be thousands of nematocysts popping open, flinging their poison threads into a victim. This usually kills the prey, or at least puts it into shock, which basically means the prey is helpless. After the nematocysts have done their job, the tentacles pull the prey to the cnidarian's mouth. The prey is then forced into the mouth, either the whole thing if it's a small animal, or bit by bit if it's larger, as the tentacles break it down into smaller pieces. Once the poison arrow is spent, a nematocyst will not produce any more arrows. Instead, it breaks down and is absorbed into the cnidarian's body. Then a new nematocyst grows in its place. So once this one's used, it gets absorbed into the body, and then a new one will grow in its place. Okay, so it's only used one time. Okay. Most sea anemones and coral polyps have short stringed nematocysts that can't penetrate all the way through a person's skin. Nevertheless, they easily penetrate smaller prey like the plankton and small fish. Jellyfish, on the other hand, have nematocysts that can penetrate human skin. As a result, while a person will not suffer from the sting of most corals and sea anemones, the sting of a jellyfish can be painful. It can even be deadly. If you happen to be stung by a jellyfish, try to get some vinegar on the stung area immediately. This neutralizes the nematocyst poison, reducing the pain that they cause. Creation confirmation. Some scientists think cnidarians are simple animals. These scientists consider cnidarians to be early animals, uncomplicated in their design because they were produced by natural processes very early in Earth's history. However, their nematocysts are some of the most complex animal structures in all of creation. They fire quickly, accurately, with devastating consequences to prey. How in the world can scientists think that the animals that build them are simple? Remember, once a nematocyst is used, it decays away, but the cnidarian that used it simply builds another one in its place. In other words, these supposedly simple animals not only have fully functional weapons they can use to attack prey, but when those weapons are spent, they just build more. Can you think of any weapon made by our military that can continually regenerate ammunition when needed? Even the best of human technology pales in comparison with what these simple animals can make. This shows us that these animals are not simple. They are elegant creations designed by God. Page 188, we'll start our section on jellyfish, and then we'll continue on tomorrow learning more about it. Okay, so you see the white spotted jellyfish on page 188 in your picture. Jellyfish are cnidarians that usually prefer to hang out in warm water, the same as people do. They move with the currents because they are zooplankton. Some jellyfish can't swim at all. They simply float in the water and get carried wherever the currents go. Other jellyfish can swim, but they cannot swim strongly enough to overcome the currents. These jellyfish have some say in where they are going, but in the end, the currents really determine where they will end up. Some currents take jellyfish out to sea, while others bring them right up to the beach where they can get caught in waves and thrown onto the sand. They really can't choose where they will end up. So if a jellyfish stings you, it was not chasing you down. Either you accidentally bumped into it or it accidentally bumped into you. Once that happened, its long tentacles only did what comes naturally to the jellyfish. Despite the fact that jellyfish don't have brains to process visual information, they do have eyes that detect light from dark. This allows jellyfish to discern up from down, which is very important for those that can swim. A jellyfish that can swim pumps its medusa open and closed, which pushes water away from the jellyfish. As a result, the jellyfish moves in the opposite direction. Generally, a jellyfish does this to escape predators by rising to the surface at night and sinking to the deep ocean during the day. Of course, near the ocean floor, they have to watch out for sea stars, which love to eat jellyfish. Their main predators, however, are squids and sea turtles. Do you remember which sea turtles hunt jellyfish? That's right, leatherback sea turtles love to feast on jellyfish. It is amazing that huge leatherback turtle survives on a diet of jellyfish. After all, jellyfish are mostly 95% water. If you took a 400-pound jellyfish, yes, some jellyfish do grow to be that heavy, and you removed all the water from it, it would weigh less than 20 pounds. The jellyfish is basically 2 layers of skin. The outer layer is called the epidermis, which is the name scientists use when they talk about your skin. And the inner layer is called the gastrodermis. Between these 2 layers is a jelly-like substance called mesoglea. Okay, so if we were to break a jellyfish down, the outside is the epidermis, which we call skin. Okay, and the inside is the gastrodermis. Okay, and the jelly-like substance that's in between, which gives it the name jellyfish, is called mesoglea. mesoglea. If you ever find a jellyfish washed up on shore, look for a fish inside its transparent body. If a fish was eaten a while ago, it will appear white because most of the nutrients have been absorbed, but you can still discern its shape through the transparent skin of the jellyfish. The favorite food of most jellyfish is fish. Jellyfish can be as small as the tip of your finger with tiny tentacles, or they can be as huge as a patio umbrella with tentacles that dangle hundreds of feet below. Okay? If I'm on a 4-story building and there's a jellyfish, it could reach all the way to the ground. The tentacles could, and even higher. Okay? Do you remember that the lion's mane jellyfish rivals the blue whale as the longest animal in creation? It has tentacles that can be over 100 feet long. However, you do not need to worry. You aren't likely to encounter this enormous creature unless you spend time in the deepest parts of the ocean off the coast of Japan. Thankfully, most jellyfish have medusa that are about the size of your face, and their stingers are uncomfortable but cannot cause serious harm to people. Jellyfish tend to congregate in swarms. These swarms are called smacks. So if you see a bunch of jellyfish together, you call it a smack. If a smack gets very large, it can be miles long and contain thousands and thousands of these creatures. When a smack gets that large, it's known as a jellyfish bloom. No one is sure what causes a jellyfish bloom. Most jellyfish blooms are found far out at sea. However, lately, Japanese waters are swarming with giant jellyfish. The Japanese consider it an invasion. When fishermen try to haul their catches of fish, the nets break under the weight of the many large jellyfish that are caught as well. This affects the entire region because it makes fish, the main food of the Japanese, harder to catch. In fact, the countries of Japan, China, and South Korea are working together to figure out what to do about these creatures. No one is sure what the sudden surge of giant jellyfish is all about. And tomorrow we're going to learn how more jellies are made.